All right, I'm just going to start in on section 2, and I'll get you out of here by 10 for sure for your break, and then we'll come back for session 2. I'm just going to run through portions of session 2 right at the start. I just have a bunch of reference slides that are fairly important I want to touch on. So a lot of these, and we have them in the printouts. We tried to make sure the printouts are big enough so they're legible so you can read all these. We're going to provide you with the PDFs after, and the presentation is being recorded so you can review it again later. But these are all a lot of references that I utilize when I'm doing reviews for projects. The first one here is State Water Resources Control Board 303D list. So this is again from the Clean Water Act, where they require each state to identify impaired water bodies, what they're polluted for. And so you can go to this website and you can download the GIS data, and then you can just make an MXD drawing in GIS. So when you're doing a review, you can go to that parcel specifically and say, okay, where's that draining to? What's the downstream water body? Is it impaired? This is also very important for the engineers to identify and properly discuss them within their drainage report as to what BMPs they're selecting and why they're being selected. This list is updated every 2 years by the state, and as new TMDLs are developed and approved, they are removed from this list. So every 2 years, it's good to go in here and download the new GIS database, because some things may have changed. Sometimes water bodies will be delisted, showing that they're not having impairments anymore, so they're no longer on the 303D list. That's a pretty arduous process, but it does occur. And I have the link there as well for that website. This is the state SMART system. So this is in particular for the state construction general permit and state industrial general permit. And basically the public user menu that I circled there in green is where anyone can click on. It can be your neighbor, it can be if you're doing reviews, if you're the engineer. You can click on that, type in an address if you know there's construction going on and they're not cleaning the street correctly or something, or you're upset. You can go in there and find out where it is and make a complaint. You can find out if they have a stormwater pollution prevention plan, who the site contacts are. I use this a lot for checking for like the common plan of development. So if I go in and say, okay, this development I know it was developed under this owner, I can go in there, search by owner, see if they've ever had SWIP for that development. Lots of times the engineers of record don't come on maybe 5 years later and they don't know that it was developed like that. And they may be looking at it as a single parcel as opposed to a large development. So I can check if they need coverage under the state construction general permit. It also has the industrial general permit on there, so you can search by industrial sites. You can search your local mechanic if they're doing stuff outside. You can check to see if they have a SWIP. If you're doing project reviews, you can verify on here that documents have been accepted, so that the applicant says, oh yeah, we have a WDID number, this is it. You can go on here, type in that document number, and it'll pop up saying, yes, okay, they have a stormwater pollution prevention plan that's been accepted by the state, so they now meet that IGP requirement. The Ventura County Real-Time Rainfall and Historical Data Interface. So I use this quite a bit just for monitoring for my own ideas here for monitoring stormwater and rain events. So this site allows you to see the real-time rainfall at any rain gauge throughout Ventura County. So all the different dots there, whether it's yellow or green, those identify all the different rain gauges that we're actively monitoring at any time. You can, on this site, you can also download historical data, how much rainfall is typical for one area compared to another. You can also set up different intervals. So this, what I have shown here is the last year's rainfall events, how much rain fell in each location over the last year. And then you can also check how much has fallen in the last 24 hours, how much has fallen in the last 72 hours. You can check those different limits and identify them. So this is a lot of good information here when you're doing hydrology reports and that. You can download all the data you need. Next one is the Regional Water Quality Control Board's TMDL listings. So they identify all the TMDLs that are effective through the Regional Board approved by the EPA. So here's just a few for the Cayugas Creek. There's also Santa Clara River. You can search by water body. So if you're looking Ventura River or Santa Clara, Cayugas Creek, there's also the trash ones for Revlon Slough, Ventura River Estuary. So you can search all that. It also has the contact if you have any questions. It also has, and then you can check all the technical reports associated with that. So there's the TMDL staff reports from the regional board, as well as the actual basin plan amendment and the implementation schedule. So you can see within those TMDLs, what are the pollutant reduction milestones we have to meet. In 2 years, do we have to be 20% less trash? In 15 years, do we have to have zero trash? So they have a whole implementation milestone within those TMDLs to show how they're going to enforce and guide that replenishment of the water body for that specific impairment. The International BMP database is another one where they've got a lot of good information. Some places like Australia are way ahead of us. They went through a massive drought about 15 years before us, and they implemented a lot of green infrastructure, try to retaining water, sustainability. So there's a lot of stuff in here from Australia, a lot of stuff from like Washington, state of Washington, all the way from Maryland, all over the states. People are submitting their data to this, water quality monitoring data, effectiveness data, operations and maintenance costs. There's a bunch of stuff in there. It's somewhat cumbersome to navigate at times, but there's a lot of good reports that can be verified, and if you're looking for specific types of BMPs, it's usually a great place to check for effectiveness. The Ventura County Countywide Stormwater Quality Management Program page. So here I just wanted to highlight in the bottom in green is the TGM errata. So every once in a while we find a couple errors in the TGM. For example, when you're designing a swale in there, I had found there was one of the exponents was incorrect. So we made that change and we're updating it, so you can always come back and check this. I believe you can also, yeah, it says Arnie on here, but this should probably be Dave Lack now, for wanting emails anytime the errata is posted, if there's new changes that have been made, so that you get an email being identified of those changes. And then in 2015, Dave Lack actually spearheaded the countywide mapping data project. So amongst all the co-permittees, we all got together, provided all of our existing storm drain infrastructure data, and then provided as-built and everything to a consultant, Hassan Khazare, and implemented everything together. So we got one geodatabase in GIS with everything in it, from storm drain channels, inlets, any kind of catch basin, drainage, culverts, things like that. So basically, if there's an illicit discharge anywhere in the county, we should be able to track exactly where it would go eventually. But it's been very useful. It also has the as-built drawings in it, populated in the attribute tables, so that if there's a certain pipe you're interested in, you can look at the drawing number and then contact that city or county and get that as-built data. And so this is kind of what it looks like in the GIS MXD that I put together. So this is southern Ventura County. All the orange are the pipes. I don't have inlet shown here, otherwise it'd kind of be really cumbersome. But all the green and blue, you have the different tributary drainage areas, streams. Those are all identified through, I believe it was LiDAR was done to map where those actually are to identify those different areas. And then we have different channels, everything kind of interlinking the 10 cities and the unincorporated Ventura County. So I mentioned LiDAR a couple times. I use it quite a bit. These are 2005 LiDAR tiles, so aerial imagery, basically shooting a bunch of points down, and then they make contours of them to identify what the existing slopes and grade are. So these 2005 contours come in small tiles. They're 1 kilometer, 1 square kilometer, or about 0.4 miles. So if you have a specific area you're interested in, you can always purchase these if you don't have them already. They are, I think they're $150 per tile, and then you can get them from this website up at the top there. But that's what I was showing on a couple of the slides with where I'm able to identify if a project's high risk or not. So a lot of people will come in and say, well, no, I don't have 20% slopes. They don't submit a real great grading plan. You can't measure it on there. It's tough with a scale sometimes. So I can even go on here and say, no, it's about 25% based on the LiDAR. Prove me otherwise. Otherwise, you're SWHR. So I use these quite a bit. It also helps with drainage delineations if you're doing your own project designs, hydrology, identifying if there's crowns in the streets, if you're having watershed to the sides, where all the drainage is. I've used this extensively for my own designs. Obviously not construction level, but for conceptual, it's 1 foot resolution. So it's 1 foot, it's not exactly survey quality data, but it's something that you can use for all your conceptual designs, and then as you come up with your construction plans, do your field survey to actually get construction level elevation requirements. For groundwater, coming into play with infiltration, lots of times coming up with groundwater information is difficult. GeoTracker is one site through the state that you can check. If you click on, I think it's this one, the points file. I'm just trying to read what that is. I can't read exactly what it is. field points. So if you click on field points, anywhere that there's been some groundwater testing in the area, whether it's for a spill on site, you can get groundwater elevation information, historical from that. So you can pull up that and it'll bring up the actual boring logs if they had to do borings for those. So it helps with just general ideas of where the groundwater table is without actually doing some infiltration testing and individual borings around your site. Obviously not every area is blanketed, but there's usually some generally close wells that you can use for reference. And then for more groundwater, the United Water Conservation District does an excellent job of their yearly reports identifying groundwater conditions, what levels different basins are at. So with those two, you can usually get a pretty decent idea what the groundwater level's at. Also, if the aquifers are confined or unconfined. If it's unconfined, the water you infiltrate is just going to basically sit in the water table anyway. It's not going to get down to the aquifer. But if it's unconfined, then it could get all the way through, which is really what we want. In the TGM, we have this glorious map of the soils, which is extremely easy to discern. I'm just kidding. It's very difficult. It's an 8.5 by 11 map, and your project is here. It's like, well, what color is it? So the soils data that was used to create that is available through the Ventura County 2017 updated hydrology manual. So I've highlighted it here and given the location for it. So you can download this. So in GIS, again, I use this all the time if I'm doing a project review. Go to that parcel, turn on the soils file. It tells me, okay, it's soil number 5. Soil number 5 is supposed to be good for infiltration. So here, back to this one, we have soil number 1, 2, 3, 4, 5, 6, 7. 1 and 2 are designated most likely terrible for infiltration. 3 is borderline, and 4, 5, 6, and 7 are supposed to be good for infiltration. That's one of the technical infeasibility aspects we'll get into after the break for getting away from retention. And so this is an example of those soil files that I've got in my MXD. So here I've just got the different watersheds shown: Ventura County, or Ventura River, Santa Clara River, Cayugas Creek, Malibu Creek, and then some of the coastal drainages. Now in this, I've removed soil number 1 and 2, which is supposed to be poor for infiltration. And the green soils are supposed to be soil number 3, which are borderline for infiltration. And soil number 4 through 7 I lumped in as the blue. So you can see where the really good infiltration areas are supposed to be. And unfortunately, it's right along the creek beds generally. So a lot of the times it's not right next to where you need them if you need to do infiltration. But it's a good reference point again for different areas to see, okay, well, I think I should be able to do infiltration here. We should do our concept design as infiltration until geotechnical shows us otherwise. Another soil reference is the Web Soil Survey. So this is another one where this is the government center I've highlighted, created the area of influence for that project is the green square, and then it identifies what those mapped soils are. And you can click on each one. So on the side here it says there's this one here is 46% of the site is that one soil type. So I just look at that one and say, okay, well, what does that entail? So it gives you a detailed what that type of soil generally consists of. And an important one we'll get into detail is in the second part is the KSAT value, or generally how quickly water flows through it. They do have that in there, so you can get a general idea of, am I going to be able to infiltrate? Again, all conceptual, but it doesn't hurt to have more information up front to make your decisions as to what BMPs you're going to be selecting. All right, and then I'll get into the technical infeasibility to start session 2. So if we want, we'll break right now. And unless we have any more questions right now before we break? No? All right, so we'll give you about 20 minutes, so we'll start about 10:05, if you could be back by then. All right, so we'll continue on here with session 2 in the wonderful world of technical infeasibility. So within the technical guidance manual, there are 16 different conditions that could potentially qualify any project for technical infeasibility. The primary one is if the soils aren't infiltratable, as number 1. So even in the technical guidance manual says if you have a soil number 1 or 2 per that map in the technical guidance manual, as well as the GIS shapefile, you can technically go for technical infeasibility without infiltration testing. I always recommend infiltration testing. The TGM doesn't require it, but it does make a lot of sense in the fact that just from a standpoint of not knowing how quickly water is infiltrating can make a huge impact on your project. I'll show you a couple examples later on too of where I thought I'd have good infiltration for one of the projects that I was managing. Did a minor conceptual design, went for grant applications, and had to change the whole thing after we did infiltration testing. So we'll go through that. The main thing for technical infeasibility, we have the seasonal high groundwater is less than 5 feet below the bottom of the infiltration BMP. So if groundwater is really high and you can show that, either through infiltration testing is generally how you do it, then you can qualify for technical infeasibility. I do want to identify it says seasonal high groundwater. Most people take that as the maximum measured elevation of the groundwater. The technical guidance manual actually has a specific way to calculate that, and it's the average of the seasonal high. So even though your max might be 5 feet below ground surface, the average over history might only be 10. So it's accounting for that fluctuation from drought seasons to wet seasons to allow more infiltration projects. So a lot of people just look at it and say, okay, high seasonal groundwater in 2005, after we had all the rain events there, was 5 feet, can't infiltrate. That's not true. So you need to look into the technical guidance manual to see how that's actually calculated. And then you can refer back to some of the geotechnical websites on the soils, the groundwater stuff that I gave you for references before the break to identify what that elevation is for your design. The soil numbers 1 and 2 I touched on, and then we have the site-specific infiltration testing. So it has to be, your infiltration system has to be able to infiltrate faster than 0.5 inches per hour. That's field measurement. It's not your design rate, and we'll talk about that and how we incorporate safety factors into our design. So another example of how infiltration testing is the way you should go is you might plan for the worst case. Okay, I'm going to say worst case scenario, I have 0.5 inches per hour, and then you don't have much information, so your safety factor is large. All of a sudden, you got this massive BMP. It's going to cost a lot of money. Whereas if you did infiltration testing, spent some money up front, you might get very valuable information. Say, well, I can't even infiltrate in the first 5 feet because it's clay, and then but at 10 feet, I got great soil. So you can do a subsurface infiltration, and maybe it's infiltrating at 8 inches per hour. Now your BMP is a fourth of the size it needed to be, you originally had it at. So it's very important to kind of do that geotechnical analysis up front for finalizing your designs. There's also various setbacks that are required. So 100 feet from groundwater wells, drinking wells, springs, 50 feet from slopes greater than 15%, unless an alternative setback is established by a geotechnical engineer. Same thing with the building foundations. A geotech can establish a different one, but in here the general number is 8 feet setback from foundations. Any sites with documented potential groundwater pollution. So again, that GeoTracker website that I showed in the references, you can identify if there's been spills at sites previously. Often very important for redevelopment sites. Say it was a gas station at one point, and now it's being developed into a Starbucks or something. You want to infiltrate water. It might not be possible based on past contamination. The other option is for harvest and reuse. You cannot provide sufficient demand. That's one part of the technical guidance manual I'm not very fond of. Is it really, the way it's written, it kind of deters harvest and reuse in a way that it requires you to utilize 80% of the capacity you've captured and retained within 3 days so that you have enough volume to capture back-to-back storms. So hopefully people aren't irrigating after a big rain event. That's generally when you turn off your automated systems and that. So it's kind of odd that they would require you to use 80% of your demand 3 days after a rain event, because generally that water is just being used for irrigation anyways. I've only run into 2 different situations where it was actually came in to be applicable and was utilized for post-construction, and those are both in farming aspects where they're doing development of barns and some roads, and they put in line detention basins with a pump system to reuse it for their agriculture. So that had enough demand to be able to meet that. But for residential general development, it's very tough to incorporate rainwater harvesting in the current framework. Sorry, I'm just going to turn this on here. So the next slide is kind of going back to some of the questions that I was getting at the end of the first session, identifying effectiveness of BMPs. So this is table 3-4 out of the TGM. And it identifies the different classes of pollutants, whether it's sediment, metals, nutrients, pathogens, and again gives kind of a hierarchy that the TGM ranks these BMPs. As you can see, pretty much number 1 on all of them. I think there's maybe one where it's number 2. Retention BMPs, infiltration, is listed as the most effective. So there is the basis of the technical guidance manual identifying these are the most effective. We're going to require them unless they show us they can't do it. So that's really what this table alludes to. And then number 2 for most of them, it basically says equivalent performance, biofiltration BMPs, wet detention basins. So all that goes into the same thing, saying like cartridge media filters are in there for a few, sand filters. So all those are generally assumed to be about the same in effectiveness for pollutant reductions. So you can choose from any of those. Proprietary BMP selection. I had to dust off the pages of this part of the TGM. I've actually never referenced this, so when I was going through this, I'm like, well, I should probably put it in there so people know it's there, but I've never used this myself. For proprietary BMPs, in order to allow like a Filterra device or other types of biofiltration or cartridge media filters, you're supposed to show equivalency based on these expected water quality objectives listed in this table and effluent concentrations expected coming out of your BMP. So this is in Appendix D. Like I said, just usually skip over that when I'm in the technical guidance manual, but it is important. It's a good reference. I was looking through it that you can check and see what kind of limits are expected, and does give you a comparison. If someone is saying they want to do a cartridge filter because it's better at metals removal or something, you can reference to this. They say that they have a 99% removal rate. They have some white papers of third-party testing showing that that's the way it is. Then you can kind of, again, it comes up to the discretion of the reviewers, but it does give you a reference to go back to if you need it. And that just kind of touches on Bio 5, which is proprietary biofiltration. The fact sheet on page 6-164 of the TGM lists a bunch of different options, like modular wetlands is one of them, Filterra is another. There's a few other devices. This is also constructed in 2011. Since then, there's been a whole plethora. There's way more vendors with these types of devices. There's a whole vendors coming up with multiple devices to fix different situations, different media types. So it's really, that's just a starting point. There's a ton of them coming up, and hopefully we can update that as part of the new permit as well so that people have a more extensive list to go by. For planning your BMPs, Table 4.1 outlines the general rule of thumb requirements for post-construction BMPs. So if you're doing infiltration, you should generally plan to have 3 to 10% of your site dedicated to it. Obviously that can change if you're doing subsurface infiltration, so you can put it beneath your street or beneath the sidewalk, things like that, so you don't lose any surface use. But these are just general rules of thumb. Biofiltration, sand filters, 0% to 5%, cartridge media filters, same thing. And then they kind of go on further in the TGM with Table 3.1, which is the space requirements per land use. So with this one, they basically identify if you're doing new development compared to redevelopment, how much of your project site you should dedicate or plan to dedicate for your site. Generally, we're just trying to have the engineers designing these plans to look at these and start thinking of it up front. There's nothing worse than going through a whole design and then you have to reject it. And like, you're only human, I feel bad about it, but if they're not paying attention to the rules and the requirements they have to meet, sometimes it's a very costly redesign. So we're hoping that people become more familiar with this so that they start planning these things up front, and really needs to be a focal point of any design of new development or redevelopment. So for further planning tools, as part of the technical guidance manual development, we also created the TGM tool. So this is a spreadsheet that outlines the steps of how to size and identify how much water you're going to have to retain on site. So here's the location for it. Again, it's on that same page we referenced before for the TGM errata, but you can download it here. And this is just an excerpt from that. So this is step 1 and step 2. For those of you that may not know, the TGM has a 9-step process for selecting BMPs, sizing them, implementing them on a site. So this goes through the first 7, which is the design of or applicability. Does your project apply for, is it applicable for post-construction? So this goes through the 10 requirements of, are you disturbing more than an acre? Are you implementing more than 10,000 square feet of impervious surface? Or are you doing a parking lot that's going to have 36 parking spaces? Or are you doing a hillside home? So it identifies what your applicability is. Generally, it's not, again, required, but it is something that I know the city of Camarillo, I believe, uses this significantly. I've seen it submitted to me. I don't require it. But it is a good planning tool, especially up front, to identify and compare kind of what BMPs you think will be able to do and which ones you're actually going to implement and how big they are. This is generally discussed in the drainage report anyways, but it is a very helpful tool to utilize. A lot of the boxes are colored, so you'll see the blue boxes are either yes, no, or like a text field if you need to describe your site conditions or why you're not doing a certain BMP. And the green ones are numerical fields. Once you're done this entire spreadsheet, there should be no more colored squares. So once you fill any data into them, they go back to a white color so that you know, okay, I missed this part or I missed this part. So it's just like a self-check process that's built into the tool. So in Appendix E, to supplement the TGM tool, we have Appendix E, and these are the detailed BMP fact sheets, or worksheets, sorry. So these are the ones I mentioned in the first session that outline exactly, if you're doing bioretention, you go to that spreadsheet, or this worksheet, and it brings you step by step through the process of identifying what your stormwater quality design volume is, and then identifies how big your BMP needs to be based on how much of a filter bed you're going to be doing, what is the ponding depth, that surface you're going to incorporate, and all those things directly relate to the details on the plan. So we can compare and contrast as we go through reviewing it, but it also helps the designers appropriately select and size these BMPs. With these, there's also the blank forms that you can utilize, and then there's an example filled out for each one, identifying, okay, for a site 10 acres, this is exactly how it's filled out. These are the numbers, so you can check your own numbers as you go. This is figure 2-1 of the TGM. So this outlines the 9-step process within the technical guidance manual for appropriately sizing BMPs in any project. Step 1 is just applicability. Does it apply? Any of those 10 new development or the redevelopment applications? So those are the first steps there. The second steps are site conditions. Oh, sorry. So here's the applicability in the top, and then site access is 2, 3 is design principles, 4 apply source control measures, and then section 5 is really the guts of the design. That's identifying your drainage areas, how big your BMP is going to be, which one you're selecting. And then we have 7, which is applying treatment control BMPs for areas that are either pervious developed or your effective impervious areas, which I'll touch on here. And then step 8 is hydromodification and flood control, and 9 is your operation and maintenance plan. So over the next few slides, an hour or so, I'm going to go through this process. I'm not going to go through 8, because 8, we really don't have hydromodification requirements in this MS4 permit. LA County, Orange County, South and North permits, pretty much everyone else in Southern California has it. We are falling under the interim hydromodification requirements. We did submit a hydromodification control plan, I believe it was in 2013, to the regional board, but it hasn't been effective yet, and it's not implemented into our MS4 permits. What that really is it requires certain projects, if you're located upstream of susceptible water bodies that are natural channels that are susceptible to erosion, things like that. So it's not an engineered concrete channel or something like that, where hydromodification and reshaping of that water body based on excessive amounts of water down it would require additional BMP sizing. So right now the general design criteria is about the first 3/4 of an inch of rainfall on a site you need to retain. With hydromodification, that goes up to about the 95th percentile storm in general. So it could be significantly a lot more water depending on where your site is. And that is going to be a very critical aspect of the new permit coming in, is how that's going to be implemented. I know there's some cities that don't have any hydromodification issues because they all have concrete lined areas. Unfortunately, the county doesn't, so I'm sure it's something I'll deal with a lot. And then 9, we already talked about maintenance plans. I might briefly touch on it again later, but we're mainly going to be focused on steps 2 through 7. So this is figure 2-2, which is the subset of step 5. So step 5 is actually broken into 5A, B, C, D, and E, and then it goes on to step 6 and 7. 6 I'll touch on as well briefly, but it's not one we're going to spend time on. So the design of BMPs generally revolves around this term, effective impervious area. It's the portion of the surface area that is hydraulically connected via sheet flow over a hardened conveyance or impervious surface without any intervening medium to mitigate volume. So basically, the whole thing of retaining volume is you have to retain it to, you're allowed 5% effective impervious area on your site. So there's 5% of your site you do not need to retain the water on it. But the TGM still says you need to treat that water before it leaves the site. So it doesn't make a lot of sense to me to put 2 BMPs, one to treat your 5% EIA, and then 1 retention BMB to do 95%. You might as well do everything there and be much more efficient maintenance-wise and design-wise. But lots of times that's not even possible depending on site constraints. The last point here on biofiltration BMPs, if you're not able to reduce the effective impervious area to below 5% using retention BMPs, then that's where that penalty comes in, where if you go to biofiltration BMPs or other treatment devices, you have to treat 150% of that flow that wasn't retained on site. So here's an example. It's kind of a complex, kind of an annoying part of the MS4 permit. It was in the LA County permit, but it's taken out in the 2012 one. So I'm kind of hoping this actually gets eliminated from the new permit we're going to be seeing as well. Because it's a point of confusion for a lot of people. And it really doesn't make a lot of sense to me to implement it. Just as I mentioned before, there's 5% EIA, you got to treat it anyways. Why would you do a separate BMP for it? So in this example, we got a 10-acre site. 2 acres are going to be undisturbed all around the perimeter. 2.5 acres are going to be re-landscaped, and then you got 5 acres of impervious surface in the middle for parking, and maybe that's a house. And then you have a driveway, which is 0.5 acres. So in this example, we have the first calculation is, okay, well, I'm allowed 5% effective impervious area that I don't have to retain on site. So that's the first calculation, is what is my maximum allowed EIA? So your total site is 10 acres, times it by 5%, you get 0.5 acres you don't have to treat. So for simplicity, I just show the driveway as the 0.5 acres here. And this is right out of the technical guidance manual. I think it's figure 2-2, I believe, but don't quote me on that. And then the next thing is calculate, okay, what's my impervious area? So you've got 5.5 acres here. So you got the driveway area and the parking and the home. You got 5.5 acres, and you have 4.5 acres of pervious area. So the area you need to retain is the impervious area minus the EIA area. So you have 5.5 acres minus the 0.5 acres we just calculated for the effective impervious area allowed just to be treated and released. So you have 5 acres of this site you need to retain on site minimum. And then your area treated, which is your, as I mentioned, you need to treat this stuff. So the 0.5 acres of the 5% EIA plus the TGM identifies any developed pervious areas must be treated. So even landscaped areas, you need to be treating those before they leave the site. That's a common missed item amongst developers, designers, plan reviewers. I'm guilty of it myself a couple times. In lots of instances, this isn't possible. It's pretty difficult to take this site, for example, if it's elevated above the street it's draining to in all directions. How are you going to treat that water? You're going to have to do some sort of work with your grading, put some sort of site perimeter berm around it to bring it down to treat it. It can be very difficult in some areas to do that. So again, that's where discretion comes in. We got to make sure that to our satisfaction as, yes?
Just a minor thing. It has 0.5 plus 2.5, and it has equal 5 acres. Is it supposed to be 3 acres?
Oh, yes. Okay. Yes, thank you.
You're welcome.
So yeah, it really comes up to discretion in this point. Is we want to make sure that any applicant's doing the maximum extent practicable. In some cases, it's not going to be possible. In many instances, in unincorporated county where I am, there's a new house is going up where they might have to do like a half-mile driveway to get to the house. And that driveway connects to a street that has no storm drain system. So if you're doing an EIA calculation, they're going to calculate that bottom portion of the driveway, but if they can't do infiltration because they're on a rocky hill, then they have to go to biofiltration or some other type of treatment device. And for most of those, you need elevation differences. So you need to be able to have about 4 feet of drop to be able to put in most proprietary devices or like cartridge filters or even modular wetlands with a horizontal flow through them. So you run into a thing, well, if they're not discharging to any storm drain system out there, they're discharging to the street, you might run into that fact, well, if they got to chase that grade up the driveway. So they might have to go up maybe 50, 60 feet up that driveway to catch 4 feet in order to have the elevation drop to do treatment. So then what are you doing with the rest of that driveway? You can't feasibly treat that. So there is some discretion involved with all these types of reviews. So I'm going to go through a site example. So this is a redevelopment that I'm going to walk through. I'm going to use this as our example to go through all 7 steps of how to design BMP. This was developed right when the permit came out. I believe it was Geosyntec that kind of put this together as part of their initial training for the technical guidance manual. And it's a good example of how to implement everything, so why I'd reinvent the wheel. So project information, this is a redevelopment of a center, highly urbanized area. Site is covered by building, roof, and parking lot. It's 12.2 acres, and it's going to be 95% impervious. So this is step 1. Is it applicable for redevelopment? Yes, the project will trigger the redevelopment requirements. And then there's a couple other aspects in here. A project not located within an approved RPAMP. So that stands for Redevelopment Project Area Master Plan. I have never run into this. I haven't had anyone say, no, it's in an RPAMP. I'm like, oh, okay. But so I've never run into this, but it's in there. So if there is one that you're available or you're aware of in your area, that plan supersedes this technical guidance manual. So whatever's been approved through that plan, they're able to go through with those water quality requirements rather than the full 7-step process we're going to go through here. And then is the project indicated for step 1B or 1C? And those are both the hillside homes. So step 1 and B up in the top right here. So that's step 1C, that's if it's a highway or a street, 10,000 square feet or more. 2 of those other that I highlighted and the single family hillside homes within the project applicability. Step 2 is just collecting site information, and I put all the reference sections within the technical guidance manual here. So it's section 3.1. So for this specific site, we have less than 15% slopes. We did our research on geotech, there's no geotechnical hazards. Ventura soil type should be number 4, so it should be good for infiltration. And the seasonal high groundwater is greater than 10 feet as calculated, so we know that we should be able to meet our 5-foot separation from groundwater for any infiltration device. And there's no setback requirements because there's no groundwater wells nearby the site.
Can you elaborate just a little bit on the geotechnical hazard?
That would be if the setbacks for buildings, as well as if there's liquefaction issues in the area. If you're adding water, you're infiltrating water, it could add to liquefaction issues. If there's certain slopes, you need to have setbacks from it, or if there's, in the past, like the example I'd mentioned before, if it was a gas station and there's a spill there or documented contamination somehow, like a brownfield site or a Superfund site, things like that, then that would be a requirement that wouldn't allow infiltration, and that would be considered like a geotechnical hazard in those areas.
And also, on the slope, 15% average, what areas are you calculating?
Sorry, for the 15% slope?
15%, yeah. Is it for developed portion or undeveloped the whole site?
For this one, it was just identified as less than 15% because the greater than 20% is the trigger for hillside or high-risk sites. So basically, that's just put in there just to identify this is not a high-risk site in this case.
I'm just saying, how do you determine that trigger if you did have a site that was steep?
The one we do is with the contours, the LiDAR contours that we discussed in the first session. You can just put those, overlay them over your site to see what the existing surface is. In this case, it's a redevelopment, so it's all going to be fairly flat. It's already a constructed parking lot. But if it's an undeveloped site, it's fairly easy to identify that from, you can even use Google Earth now. You can do sections in Google Earth, and it'll give you general profiles for the elevations. So that's just part of your site information initially, is you want to identify if it would qualify for certain geotechnical setbacks that they would need to have. So in this case, the 15% was one of the setbacks that was set in the technical infeasibility as well. So it said if slopes over 15%, then you have to have a set, I think it was 50 feet from that slope from any infiltration device, or another established setback as identified by a geotechnical engineer. So here is step 3. So this is applying site design principles and techniques. So in the table, there's 6 different things to review, different sections talking about how you should site plan How are you going to conserve natural areas, minimize land disturbance, minimize an impervious cover when possible. It's all part of the green construction, kind of trying to minimize the impacts by minimizing impervious surface wherever possible, and then applying LID impacts at various scales, and then implementing the IWRMP, and that is the Integrated Water Resource Management Plan. In 2006, the one was created for the Watersheds Coalition of Ventura, and that basically, the TGM meets those needs because it's striving for the 4 goals outlined in that plan, and those goals are generally to conserve and augment water supplies, protect people and environment from flooding impacts, protect and restore ecosystems in watersheds, and provide water-related recreational, educational opportunities. So it's in there, but it's something, again, I've never looked at the plan. I'm not aware of it, but this whole process just asks that at least these things are considered when you're doing your designs. For step 4, it's applying source controls. So before you get into BMP design, they want to make sure that any kind of site activities are going to be appropriately designed. So your outdoor trash areas, you want to make sure that those aren't going to be draining right into an inlet. Loading docks and that, same thing. You don't want any, if like it's a produce shipping dock or something, you don't want all the produce that falls on the ground rotting, being washed off into a storm drain system. So there's specific fact sheets identified in the technical guidance manual of how to design those, and those should be discussed or shown on your design plans. And it's rare when they're included within the drainage reports, but it's always nice to have it. Number 1 there too would be storm drain stenciling. So any site that redevelops, they should have the either placards or stencils on there identifying don't dump to ocean as part of the public education outreach for the programmatic part of the MS4 permit. And feel free to, if you have questions on a specific slide, again, just put up your hand and we can, yes?
Those are prescriptive, right? They're required, always.
They are. They're supposed to show, then that's, in this case, we went through and said, okay, we're going to do SW or S1, outdoor trash and storage, and loading docks. The other ones don't apply for this type of project.
So for every S1, S2, S3, there's prescriptive requirements.
There
All
is.
those need to be incorporated in every new or redevelopment project.
They're supposed to be, yes. One problem, and I know I've talked to Mike and the Planning and Land Development Committee about this as well, is the 2000 MS4 permit with SQUIMP had an actual template attached to it, a step-by-step process that every person fills out and is supposed to submit. The PCSMP and the 2010 permit didn't do that. And before I went to the county, I did a lot of post-construction design for like North Orange County, South Orange County permits, San Bernardino, Riverside, their water quality management plans, as well as some in LA County, and they all have a set template that you fill out when you're doing your design, which makes it so much easier because all this stuff is in there. Whereas right now, we're requiring every person to look at a TGM document that's 200 or 500 pages with appendices and figure out exactly what steps, everything they have to do. And a lot of people just glaze over it, do the sizing design and then the worksheet, and they hand it in, but they haven't addressed the other steps. So again, it's depending on the size of the development or the discretion of the reviewer. Sometimes you can be pretty picky about this stuff because it's supposed to be included. So step 5, as I mentioned, this is applying BMPs to reduce EIA to less than 5%. So this is like the guts of the whole design section, so it has its own flow chart for it. Within that flow chart, the first step is to calculate the allowable effective impervious area. So for this project, we got 12.2 acres we're disturbing as the project area, and 5% of that we don't have to retain on site. We can just treat it and release. So we got 0.6 acres of that EIA. And then step 5B is calculate what needs to be retained. So in this case, we have 12.2 acres times 95% impervious area minus the 0.6 EIA acres. So now you have 11 acres of that site that you need to retain on site. So within step 5, step 5C specifically is when you start sizing, okay, how much water do I have to retain? There are 4 different methods that are approved through the technical guidance manual. I would say 99% of the time, everyone goes right to 0.7 inches storm event, which is method number 3, and that is what the whole TGM is based on. Every example in here is all 0.75 inches, although in Appendix E, I think it is, they have the other 3, so let's see if Appendix E or not. Appendix E, they do identify methods 1, 2, and 4 and how to follow those. So depending on where you are, this could be beneficial, it could be detrimental to the size of BMPs, but it's the easiest one to implement, so that's what most people go for. For instance, the 0.5-inch storm assumes that rainfall is the same all over Ventura County. So if you're up in the hills, you're going to get more rain, this would be beneficial. If you're in an area where it doesn't rain as much, you might be able to show through the other methods that it would be less than 0.75 inches. Yes?
Can you talk about how this is different than the LA County permit? And I think in that permit it says whatever's greater from the 85th percentile. I don't know if I'm correct, but do you recall?
It's been a while since I've worked with the LA permit, so I can't speak to that exactly. But I believe you're right, is they want to go with the greater than to make sure you're maximizing the water retention. Here, they give you options. This will most likely change with our new permit.
You think it's going to change?
I think it will.
Just
Yes.
pointing out, there's like a table where, depending on your project size,
That's correct.
it tells you which one you can use.
Yes, I believe it's on the next page of the TGM after this. Oddly enough, in section 5, when it talks about this, it doesn't say anything about that table. It doesn't even bring it up until section or step 7, when we're talking about treatment control BMPs, and they actually identify that yes, there's of these 4 methods, you can use any of them for any project less than 5 acres. And then as soon as you get to 5 acres or more, you're not allowed to do the 0.5-inch storm, generally is what it says on there. That's, again, I think it's going to the same assumption that rainfall is the same everywhere. They want people to be more realistic with what their BMPs are actually going to be sized. But for the sake of the example that I'm going through and the BMPs here, we're just going to use the 0.75 inches. I haven't had an issue myself with accepting the 0.75 inches if a project's even over an acre. Generally, the reasoning for that is if the project's over 5 acres, they have to do some fairly significant detention to meet grading requirements for the pre and post effluent requirements. So as part of that, the basins are generally much oversized than they need to be. But I do make a point to comment on that when necessary. Yeah. So moving on with table 5C, to calculate the overall retention volume for this site, you have 0.95, which is the coefficient, runoff coefficient for impervious surfaces, times the 11 acres that we determined in the last step would be the area we need to retain, times the 0.75 inches for method 3, divided by 12 inches per foot to get it to 0.65 acre feet is for the entire site. That's what we're going to have to retain to meet this post-construction requirements for this redevelopment. So step 5D is select and size on-site infiltration BMPs, infiltration considered first. So that's where we talked about the hierarchy, is they have to consider infiltration before they can go to biofiltration. So this is where we start getting into the actual design and layout of the site and how big those BMPs are going to have to be. So selecting from those, on here that isn't showed is infiltration 7, which is bioinfiltration. It's basically the same as an infiltration, infiltration 3 and infiltration 7 are essentially the same, except bioinfiltration is when you've established your soils are soil number 3 or are slightly less than 0.5 inches, but you still want to do some infiltration, and then you do have a raised under drain. So I have not seen one of these installed myself or even proposed, but it is an option in there. If you can show technical infeasibility for full retention, but you still want to do some infiltration, that's one way you can do it. So here's going through all the different options, saying, okay, well, for this site, what would be the most appropriate BMPs to put in? So here are the infiltration basins, not recommended. It's going to take up a lot of surface area. They got parking lots and buildings they want to have in there, so they're saying we're not going to do that one. Infiltration trench also, usually surface level, so it's probably not the most appropriate, but it's possible. Bioretention, you see in a lot of parking lots, open curb cuts, drains into an area with a ponding and then overflow. So that seems like it would be recommended here. Same with permeable pavement implementation, potentially in parking stalls and such. Could also do dry wells, but you probably have to do more than one. And then proprietary infiltration. Seems to me like that may be one of the most effective uses in this location. But for the sake of this example, we're going to go with bioretention, which is one of the most utilized BMPs that I've seen. So as part of this project, we're going to do distributed bioretention. So you can see on here the green squares, there's 1, 2, 3, 4, 5 different bioretention areas. That's showing that there's roughly going to be 5 different drainage areas. So the reason I show this, and I'm going to go off that exhibit for a second, this is an example of a single-family dwelling grading that I got about 2 years ago, where they have about a half-mile access road and then up to the residence, and there's 2 forked driveways. There's going to have the main residence at the bottom, a sports court, a secondary residence, and 2 barns all spread out along this parcel. So the reason I bring this up is ideally for any site, you'd want to construct 1 BMP, have everything drained to it in the ideal world. In this case, it's impossible. Well, it's not impossible, but it's not really feasible, is the driveways in this case are higher than the areas, the padded, graded pads for these areas. So the water running off those new impervious areas can't get to the street, because ideally you'd want to have 1 BMP at the end of the driveway to treat everything. But in this case, they can't do it. So they had to have separate BMPs at each location to treat each of those, because you're not allowed to overcompensate in one area. So build 1 really big BMP to treat a bunch of water and then let other areas go untreated. You have to treat every area. And I'll talk right here about why that's important. So that I've referenced from SQURP as well as Caltrans in regards to urbanization, and in particular these are studies of parking lot runoff. And both studies identified, and there's plenty other studies out there that identify a first flush effect. So when it's dry, it's not raining, there's oil dripping off cars, there's metal, everything like that that sits on the surface. So when it rains, that first flush of water takes the majority of those pollutants with it. So the first part of a storm, generally about the first 20 minutes of any storm, is usually the highest in concentrations. And that's really what the TGM is trying to do, is they're trying to put that 0.75 inches that you got to retain on site for every area, so that you're containing and retaining the highest pollutant concentrations of every storm. So if you're overcompensating in one area and you do 1 BMP that's massive and let 4 other areas go untreated, theoretically, that 0.75 inches really correlates to about the 85th percentile storm. So 85% of all storms, that 0.75 inches should retain that water for. So if you design 1 BMP that's really big, you end up having only 15% of the time that extra capacity is even being used. And when it is being used, it's treating generally less polluted water than at the start of the storm. So that's why if you have those smaller BMPs but have them everywhere to treat all the areas, you're treating the first flush for the entire site, which is really what the TGM goes for. So back to the example here. So I was talking about separating the different parcels. So here, ideally, we want to put everything to 1 BMP, but for the sake of the example, we're separating it into different drainage areas, and we're going to do 1 BMP in each drainage area, just to show how this should be done on most sites. So for sub-areas 1B and 6 to 6B, we're going to treat those with bioretention. So we got each of those green areas show the bioretention. We also just show the roof, saying there's 1 roof drain for each of these buildings, just for sake of the example, and where those are located, those are the yellow dots. And then the EIA area is going to be sub-area 1T. So we're just going to say that that's the 0.6 acres that we calculated at the start, that we're just going to treat before releasing it. Everything else we're going to have to retain. So moving on there, we need to consider the drainage infrastructure and the pre-treatment need. So the technical guidance manual requires pre-treatment for any infiltration device. It's kind of difficult to do in lots of locations, but again, if applicants can justify to the maximum extent practicable they're doing stuff, that we can usually approve those things. Generally, like for instance, permeable pavements. How do you do pre-treatment for a permeable pavement? You can't do it. The water goes through the pervious pavements and start infiltrating. So you don't have pre-treatment removing the sediment, which is the main problem for the O&M portion of it. So there's some aspects of it that's not realistic, but for the most part, they should be doing pre-treatment because sediment is the main concern. With most pollutants, whether it's pesticides, oils and greases, metals, they attach to the sediment. So if you can control the sediment, you can really control about 75% of your pollutants in many cases. So in this case, we're talking about pre-treatment. So in each of the inlets, they're going to propose to do catch basin inserts. which is PT2. And again, in the technical guidance manual, under that fact sheet in section 6, they do have listed approved inserts. Some of them have booms for removing extra hydrocarbons in them, like filter socks. Other of them are just mesh wires. Some of them are low profile, so if you've got a really shallow catch basin, you can put those in. Other ones are deeper ones. The main thing is you want to have some bypass in there, so there should be a built-in bypass system so that during rain events you're not causing flooding if that whole thing fills up with sediment. You could also use hydrodynamic separators. So in most cases you could look at this and say, okay, every basin or every catch basin on this site or drain inlet is going to go to one pipe and then go down and we put it through a CDS unit or something to remove all the sediments, floatables, and then it goes to a subsurface infiltration system. That's one way you could do it. In this case, we're going to separate it into 5 different bioretentions just to show how the complex calculations work for this site in this type of situation. So this is moving to the worksheets within the appendix of the technical guidance manual. And here you can see it's, we took the 56,600 square feet, which is like the 11 acre or the 1.3 acres for, I think it was drainage area 1, maybe 2B we're looking at. Let's see here. 3B, sorry, I noted it on that slide at the bottom. So we're looking at site 3B. So in this case, it's about 1.3 acres that drainage area is. We determined the pervious runoff, which is 0.05. That's taken from table E-1, and it's based on what the soil number is in that area. So in this case, for soil number 4, it's 0.05. And then we continue on down the spreadsheet, calculating the actual, or the design calculated runoff for imperviousness. And it has all the equations there, as well as all reference tables you might need to reference throughout your design of using this worksheet. And then we have the design rainfall, which is the 0.5 or 75 inches. So we are using the method 3 again, that's used throughout the entire TGM. And then we turn that into a foot value, divided it by 12 to get the value below it, 0.0625 feet. And then from that you can calculate, your stormwater quality design volume. So for that single drainage area of 3B, you'd have to retain 3,200 cubic feet. So for subdrainage 3B, we have soils number 4. For this example, it says the hydraulic conductivity from that web soil survey reference I provided before the break, where you can click on the actual soil type and it tells you what the general KSAT might be. So that's what this number is. So the range given for that soil type at this site was 1.4 to 4 inches. So for the initial concept design of this project, we're going to use the lower range, which is 1.4 inches. This is assuming we don't have any geotechnical information to back it up. So it's just conceptual at this point. So this is where the geotechnical stuff really comes into play, is these are the infiltration safety factors. So it's not, you can't just say, okay, well I infiltrate 8 inches per hour, that's what I'm going to use for my thing. So they want to make sure that the TGM requires that you put in these safety factors based on the amount of information you have for your site. So did you do a geotech report? Do you have borings all over the site so you can classify that infiltration at this one location is the same as what it's going to be over here? Did you do multiple borings? Did you do groundwater investigation? All that stuff, so that all goes into these factors. So what we have in this row is there's 2 different subsets of safety factors. There's suitability assessment, which is the safety factor A, and there's design, which is safety factor B. So under suitability assessment A, there's 4 subcategories. That's soil assessment methods, predominant soil texture, site soil variability, depth to groundwater. So all 4 of those are generally perfectly designed and laid out in a geotechnical report. So if you did all that work ahead of time, you could put 1s for all these factors, and then your safety factor would generally be half or less than what it is without doing geotechnical. So for instance, this example, we're just using that web soil survey information, which is the 1.4 inches per hour taken from that website. So the safety factors for soil assessment methods, well, we didn't do any. So we had to put a 3 factor. So it's a max of 3, minimum of 1. And then you multiply it by the assigned weight of 0.25 to get your product at the end on the far right column. Predominant soil texture, maybe they did a couple borings on site so they can identify if there's clay on top or not, but they didn't do any infiltration testing. So in this case, say, you know what, we're going to do a 2. And then site soil variability, maybe in this case they did 15 borings over this site. So they got a pretty good idea, blanketed the site, but they didn't do any infiltration testing. They can generally have a good idea of site soil variability throughout the entire site, so then they put a 1 for their factor here. Depth to groundwater, they didn't check for groundwater for some reason in their geotech report. So they're just going off of the GeoTracker website, the information they researched, so they put a 2 instead of a 3, saying, well, we have a general idea, but we don't know for sure. So your safety factor for that becomes 2 for the geotech. So any design value, and I'll show you in the next slide here too, is affected by these safety factors. These are built in for long-term operations and maintenance to make sure these are retained. So basically, if you don't maintain it for a year and some sediment gets in there, it should still be infiltrating a bit, and that's kind of what these are for, is to make sure that if they're not 100% maintained, or over the years, say over 10, 15 years, some sediment gets in there and builds up, you lose some infiltration rate, the BMPs are still able to handle that stormwater quality design volume. So here we have a combined safety factor for safety factor A and safety factor B, which is number 4. So I want to go to some examples of projects that I worked on throughout Ventura County before I go to back into the slide examples. So these again are all the soils from the GIS download from the hydrology manual. I removed soil numbers 1 and 2. So the green are supposed to be soil number 3, maybe 4, like borderline for infiltration. All the blue is supposed to be very good, soil numbers 4 through 7. So it's tough to see because I didn't zoom in on each one, but all 3 of these sites are actually located in blue areas. So they're all supposed to be very good for infiltration. So the first one was a Miners Oaks project. We went after grant funding through the county for this. I did the conceptual design, assuming infiltration, just like 15% design so we could have something to go after a grant with. Once we received the grant, part of that was the design. We're going to go do infiltration testing to validate how big those infiltration galleries, whatever they need to be, are how big they need to be. But when we did the infiltration testing, we did shallow depth borings as well as deep, so we can see, okay, well, can we do a surface level infiltration BMP? So we tested at 3 feet and we got less than 0.25 inches per hour, which doesn't meet TGM requirements. Then we tested at 14 feet deep to see, okay, well, do we need to do a subsurface deep infiltration? And even those, we only had a couple areas that even borderline met the requirements. So this is a soil number that was supposed to be good for infiltration, and we basically had clay down to 14 feet. We could have gone deeper, but the deeper you go, the more expensive it is to construct. So in this case, we revamped our entire design and went with surface biofiltration with a massive bioswale. So, and that was constructed in 2016. In this project for Oak Park, it's another grant project we did. Initially, we wanted to do infiltration again, but when we went back did infiltration testing, the same thing occurred. It's supposed to be soil number 4, which would be good for infiltration, but same thing, we found just clay everywhere, all the way down to, I think it's 15.5 feet on this slide. So even though we're just testing, it's like a 1-foot area at 15 feet, so it could be like 14 to 15 feet, that's the area we measured, or at the 2-foot depth, it'd be 2 to 3 feet or something. Like there's a 1-foot area where we're measuring that depth. We're not doing the full section, but from comparing those areas to the borings we get from the geotech that pulls out and say, okay, for this area we have clay, this is a silty loam, we can identify the variability in the soils, and pretty much it was clay all over. It's never a good sign when you pull out the drill bit and it's smeared with clay. It's always a little bit of a downer. The Government Center project. So this is one where we implemented pervious concrete through another grant project. We went through and did infiltration testing over the grounds, and same thing, it's supposed to be number 4 soil, it's supposed to be excellent. In this case, there was a clay cap that went down 13 feet. After 13, it was excellent soils. So the way we ended up designing that was we wanted to do infiltration, we wanted to propose that. So in this case, we did permeable pavements on the surface that drain into like a storage trench. Normally that'd be like an infiltration trench, and that's the end of your BMP. But in this case, it's just aggregate filled rock to store the water in between the void spaces, and then those overflow into dry wells that bring the water down below the clay cap to the soils that can accept it. So in this case, we did our geotechnical investigations, found groundwater about 30 feet, and so even going down 15 feet, we know that we're able to meet the 5-foot separation, and we did the GeoTracker research as well to verify that the local wells that have been checked and things like that, that we're not going to be running into groundwater issues. So in this case, we have, I think it's over 400 of these 1-foot diameter dry wells throughout the Government Center below the pervious concrete. And we are able to infiltrate about 700,000 gallons every rain event using this system. So that's just one way of getting around some soil things and the more importance of geotechnical testing to find out what you can actually put in the ground. So getting back into our example, so that web soil survey information they had grabbed, it's 1.4 inches per hour. So that's going to be our P measured, which is basically what the measured rate would be in the field if we took our geotechnical testing. So 1.4 inches, then you attribute the safety factor A and safety factor B we calculated previously for number 4. So you basically take 1.4, divide it by 4. Your design infiltration rate is 0.35 inches per hour. So your BMP could be massive for this parking lot. If you think of 11 acres of impervious area and you've got to capture 3/4 of an inch across that whole parking lot, that's a lot of water. And the slower your infiltration rate, the bigger your BMP needs to be. So it just makes that much more sense to do solid geotechnical investigations ahead of time to make sure, because in this case, for example, at the government center with the dry wells, if we would have gone by the web soil survey, we could have used like 0.8 as the KSAT value. But we did investigations, and what ended up coming up was we had one section that tested at 2 inches per hour was the lowest we ever found at that 15-foot level, and it went all the way up to 32 inches per hour. So it gives us a real range that we can deal with to come up with like an average for our design sizing. Yes?
Have you ever had an infiltration rate that you thought was too high?
Not to safe, but a perfect example is our El Rio project that we constructed. We did precast pervious concrete panels out in El Rio. And our infiltration rates and infiltration testing, we actually had to narrow the hole because it kept collapsing in. It's all just sand. It's right where the spreading grounds are for United Water as well. And in that area, we're actually averaging at 5-foot depths over 200 inches per hour. So the ground is actually infiltrating faster than the pervious concrete. So the bottleneck is the BMP itself, which is kind of weird. But in that case, we had over 60 feet down to groundwater. So we felt fine. If it was maybe 5 to 10 feet, we may have not even developed that project. Yeah. Yes.
Now, during the review for the geotechnical reports, have you come up with an acceptable minimum depth for your borings to get all these readings? Because I've seen them down to 50 feet for liquefaction, some are 10 or 15. And now with the groundwater requirements and the stormwater infiltration requirements.
Yeah, I'm not a geotechnical engineer. I don't pretend to be, so I try not to dictate what people do in there. I just want to see the report. It's really up to the geotechnical engineer and the civil engineer to identify what that needs to be. Generally, at the projects that I work on, I do one shallow boring and one deep boring, usually about 15 feet, because after 15 feet, it most of the time becomes impractical to excavate that deep and do all this infiltration. Most likely, especially if you're like Oxnard, Ventura, where some areas the groundwater is really high, it just doesn't make sense. So, but I normally do that so that I have shallow and deep, so I can identify, okay, well, should I do surface level infiltration? Or can I do, like in El Rio, I can do a 3-foot trench and know that I'm getting great infiltration? Or do I need to go deeper, like at the government center with the dry wells, to actually obtain infiltration? So that's the way I like to do it, but it's really up to whatever they want to do. It's more practical if they don't have to mobilize at different locations. They just do 2 borings separate at the same location. So it's generally not that much more expensive to get them to do 2. Yes.
What's the 5-foot separation between groundwater and BMP? What's that based on?
It's the seasonal high average based on, I think it's, I'd have to double check myself on the actual wording, but it's...
I mean, why 5 feet? Has it been determined like on average after you percolate through 5 feet?
No, it's excellent question. I wish I had an answer for you. LA County is 10 feet. Ours is 5. We're probably going to be going to 10 feet, I'm assuming, with our new MS4 permit, because we're supposed to be merging with LA if that actually happens. I actually started doing some research into that while I was doing this, because I had some of the same questions, like, where are all these numbers coming from? There's even one part in the infiltration trench design fact sheet. It says if something is draining faster than 2.4 inches per hour, you have to have full pre-treatment before it. Nowhere else in the TGM is it mentioned. It's just copied over from one of the other things, and no one caught it when we were reviewing the document for approval. So a lot of it is regurgitated from other manuals. And when I kind of followed the breadcrumbs all the way around, pretty much all the groundwater stuff comes from state of Washington in their ecology department, dating all the way back to their 1992 manual, which seems kind of strange to me because it seems that over all these years there'd be better information when all this LID is being implemented, but it's still coming from a 1992 standard up in Washington and being used in Southern California. So it's kind of bizarre, and I hope that more stuff like that gets ironed out in future permits, but it's, yeah, it's a difficult question to answer. Anything else? So then going through this, you can see, yeah, your design level now is 0.3 inches per hour, so it's really small. So again, if you just reiterate in the geotech stuff, if you do good infiltration testing, you find it's either infiltratable and you have better numbers, then your BMP is going to be significantly smaller because you have actual data to work with. Here's the next sheet for the bioretention. So here we have, you enter that water quality design, so it's 3,200 cubic feet from the first sheet. And then your design infiltration, we just calculated as 0.35 inches. And then the required drain time. So here it says 48 hours for the required drain time. That's in the sheet, I'm not sure why it is, but the TGM does allow for up to 72 hours for surface ponding to drain. So this could be 72 hours if you want it to be. For the design requirements here, they have it listed as 48 hours. So moving on to this, there's a bunch of different things that then get calculated. So it's basically all based on that drawdown time. And it goes from like the D as a DF, DP valuation compares to other ones. So what is the depth of your surface ponding that you're going to allow? It has to be less than the D max that was calculated in step 3-3 above. So the reason you need that drawdown time is because you got your 48 hours, your design infiltration rate, and then you can calculate your D max, which is how much of water above your infiltration surface can draw down in that 48 hours. So that's a key component so that you can size your BMP. So when you talk about your selected surface depth, it says 1.3 feet because it has to be less than 1.4. So we don't want to maximize the design. So if it starts clogging a bit, then you're going to have ponding and flooding everywhere, or it's not going to treat the full volume it's supposed to. So then we also run into what is the section of the media. So right here we have in bioretention facilities, you'll have like usually mulch on top, then you have a amended soil mix, and they say, what's that depth here? So it's 3 feet. So they're saying we're gonna do 3 feet, we're gonna have a ponding depth of 1.3 above the surface, and then what's the general porosity of that media mix? They say 0.25, but if you specify a specific mix you wanna use that kind of follows the lines of the TGM, they do have a specific mix in here you can use, but from my experience, it's very difficult to find that exact thing locally. So you're pretty much going to have to do deviations from it. But if you can try to get as close to it as possible, it's good. And so this is all directly related to a detail. So when you go through all your calculations here, you should be able to, I can look at the plans and say, okay, 3 feet is their media. So I can look at their detail and say, okay, here's 3 feet, yes. Ponding depth, yes. If they have their ponding depth elevation set like only half a foot above, then I'm like, no, you got to raise that, which may mean grade changes, or they have to lower it down. If they lower it down, maybe they need a bar now to meet safety requirements, or so no one's falling in it. So there's a bunch of different implications that come up. So this is a very important worksheet. And then at the very end, you end up coming up with the effective storage depth of the bioretention facility of 2.05, and that's just a component of the infiltration ponding depth, as well as the actual storage available in that 3 feet. So they're saying porosity is 0.25. So of that 3 feet of media, 25% of it is being said can store water. So that's what that effective depth stands for. And then we move into the last part of it, which is they have self-checks in these as well. So that it says here, if your T total does not, and you calculate your T total here, and if it exceeds 96 hours for total drawdown of the BMP. So that includes surface ponding all the way to the bottom of the BMP needs to be drained in 96 hours, and that's what this is calculating. So remember, you can have up to 72 above. As soon as 72 hits, then you start getting into potential vector issues with breeding mosquitoes, things like that. So in this case, you have to show that your whole BMP will drain in 96 hours. Yes?
If you go back one slide, why was it 48 in this example and not 72?
Another thing I'm not sure about, I'm assuming they're just trying to split the ponding depth to the media storage, that each are going to drain equally. I'm guessing that's where the 48 came from the 48 to 96. But you can do up to 72, it's just you need to show it drains in. So you may not even be able to do the 72-hour drawdown time depending on this calculation here. So if it's over 96, you'll have to go back and redesign, which means maybe you have to do a smaller ponding depth. You're going to have to, but then you have to do more subsurface or something. So there's a different deviations you can do here. So then once you calculate your T total, it gives you that. If it's under 96, you can move on to the next portion, which is your final calculation of the square foot area of your bioretention facility. So again, this is directly related to the plan view of your grading plans or what have you. So you can look on there, you can measure, they should have it called out, bioretention facility, this square footage, and then a detail referencing 3 feet media, 1.3 feet ponding depth. If they don't have that, request it, because you need to see those elevations to make sure it's actually being sized and constructed appropriately. So here's an example of what those details might look like. So they have the ponding depth called out, and this is just out of the TGM, so it's just a rough detail, but they would show a difference, elevation difference of 3 feet, and they'd obviously have more detail if they're doing rock or what they're doing at the bottom. But that's just an example of designing for that 3B drainage area. The reason I bring up the multiple drainage areas is because you have to do that exact same calculation process for each of those sub-drainage areas. So initially we calculated our total project retention volume of 0.65 acre feet. That's for the entire project. But you have a bunch of sub-drainage areas, so you can't put all that in one location and overcompensate. You have to do that for each of the drainage areas, and that's what this shows. Is so you would calculate those same steps we just went through for all the other drainage areas, 1B, 2B, 4B, 5B, and 6B. And then when you add up all those areas of volume being treated, it would be equal to or greater than that 0.65 acre feet we calculated on the first slide. This is where we get into treatment control BMPs and the treatment of EIA areas that are allowable to not be retained on site, as well as developed pervious areas. They do go into a lot of detail here, and I think this is the one area of the TGM that I use the most discretion in. I kind of gave some examples before where this is really difficult to implement on many projects. Also, certain BMPs, they say in the TGM, if there's an impaired water body, you need to pick one of the top 3 listed BMPs in the TGM for this. Some of them, again, aren't practical, but as long as they're showing that they're doing their best, or if there's, say, a cartridge media filter and you're trying to do bacteria or metals removal, they might do like a zeolite, perlite, and activated carbon media mixture, which has got the cation exchanges you need to remove certain pollutants. So as long as they're showing they're thinking about it and trying to do their best in certain areas, then I'm a little more lenient on this aspect of the TGM. So table 3-2 of the TGM lists those typical pollutants from different land uses, and then 3-4 lists the effective BMPs per pollutant. So I just listed those for reference. Lots of times, again, it'd be nice if we had an actual template to go by so that every single applicant submits the same information, the same level, because half the time you're hunting and pecking within a drainage report and geotech report to try to find the information you need. It would be nice if it was all laid out in a template like in some of the other counties. So I skipped over step 6, and that's because step 6 is alternative compliance. And there is a step in there, and it's identified in the MS4 permit that if you can show it's technically infeasible for you to reduce your EIA to less than 30%, then you can mitigate off-site on a different parcel, or you can pay money into a fund that, to my knowledge, was never set up. And I've never run into it. I don't know if any other cities have. I don't think so. But they also have a strict requirement that it must, if you do off-site alternative compliance, it must be in the same hydraulic unit. So it really minimizes where you can do it as well. But I just skipped over because I haven't run into it. I doubt any other city has. Because most of the time you can find a way to do it on site. It's just a matter of special circumstances we haven't run into. But I think that most likely will be something, or I hope gets implemented in the next permit, that we do establish stuff like that, because as municipalities, we always have issues coming up with funds for our own projects to meet TMDL requirements. So it'd be great if there was a account set up like that, so that if someone says they can't meet it in that watershed, then they can dedicate a certain funding that we dictate what it would be per, say, impervious acre. And then we could take that funding and do our own development projects in those watersheds for our own uses. So that's an option I hope gets implemented, but we'll see if it does. Yes?
To answer Shada's question, table 6-6 of the bioretention design criteria. Maximum drawdown time of water ponded on the surface is 48 hours. The maximum drawdown time of the surface ponding plus the subsurface pores is at 96 hours.
Yep.
With a 72-hour buffer. So the calculation for the 48 hours is the maximum drawdown time of the surface.
Okay. No, thank you for that. And that was table 6-6, you said?
6-6.
Okay, so that's not in there, so if you want to write that down, that'd be a good reference to go to. So then step 7 is still applying those treatment control BMPs for the EIA areas and developed pervious areas if there are any. So then you have to identify what are your pollutants of concern. In this case, from a parking lot, it'd be sediment, maybe oils and grease, trash. And then you can utilize some of those other references that I mentioned, like the GIS layers for the 303 delisted impairments. They would list in this case if the project would be draining to the Santa Clara River Reach 1, it's impaired for toxicity. So if there's some BMPs that might be able to help with sediment toxicity or water column toxicity, then you could implement those accordingly. So here's that table, which identifies all the different class of pollutants on the left from the TGM. This is table 5-4, I think it is. But identifies what those class of pollutants are, and then on the right, the most effective BMPs for treating that type of BMP, or treating that type of pollutant. So in this case, it said in that previous slide that you can select one of the top 3 performing BMPs. So in this, you can see there's 1 is retention BMPs, 2 is biofiltration, which is all pretty much the same, and then 3. So they only list the top 3, except for nutrients, they list 4 and pesticides as well. So you wouldn't even be able to list the dry detention basin for pesticides there because it's listed number 4, so they want you to pick something above that. So in this case, cartridge media filters are selected or listed on there, so that was chosen for this example to treat that EIA area. So that's that example of a redevelopment site. I did want to kind of touch on some other subjects here. This is one project that came across my desk. So here we have a 2-phase project. Airport hangars, storage units, they all look the same. So this is generally they have like the one line of all the buildings, and then they have the drive aisles in the middle. So this project, they're proposing construction of phase 1 right now, with phase 2 to come at who knows when. So in this case, they're doing pretreatment filters in all the catch basins and drop inlets, and then everything is going to a location highlighted in blue, which is a diversion structure. So all the storm drains go to that same structure where it's got a low flow bypass and then, a low flow diversion and then a high flow bypass in the same location. So everything under that 0.75 inches would get diverted for the low flow to an infiltration system. And if it's a large storm, as soon as that 0.75 inches is accomplished, then they'll start overflowing and discharging from the site. So this is an example of a really good design at the surface level as to how to control everything with one single location. And BMPs, in this case, they chose to do subsurface infiltration with proprietary infiltration devices. So you don't lose any of the surface availability, so you still have it under the drive aisles. They have access hatches as well, so for maintenance. And then they created an artificial high point at the bottom of the development, which is right here, to make sure that everything drains this way to their area, so they don't have anything this way that they have to treat with a second BMP. So this is a good example of, at the surface level, an excellent design. Same project, looking at the geotechnical report. Here I show, it's tough to see in the scanned copy, but there are 6 different infiltration test areas and 1 pilot boring that was done for finding groundwater. And they did it at the lowest part of the proposed BMP in that east to west infiltration basin. So this was submitted along with the plans. Unfortunately, the proposed infiltration BMPs and the plans are not located where they did their infiltration testing. So it's obvious to me in this standpoint that the civil engineer came up with an initial concept design plan, said, okay, this is where we're going to put the BMP, gave it to the geotech. Geotech went out, did all the borings, gave it to them, and they didn't update it or do additional borings once they changed the location of the infiltration BMPs. The other item I wanted to mention about this is that I liked about the design, I meant to mention on the last slide, was phase 1 and phase 2 are both accounted for in the phase 1 design. So they have the infiltration system sized to treat all the impervious surface from phase 1 and the unplanned phase 2 at this point. So they know what they're going to do, but they haven't constructed it. So it makes a lot of sense to do it that way if you know phase 2 is coming. That way you don't have to restructure your storm drain infrastructure and everything goes there, so when they develop it, they're already meeting their post-construction requirements. So this is from the plans. So this is the BMP they're proposing to do, which is a subsurface infiltration system. And a couple things I like about this, on the detail for the section, they do show the groundwater elevation that matches what was in the geotech report, showing that they're going to meet at minimum their 5-foot separation. And if you look at the side, it's actually about 6.5, almost 7, but they say 5-foot minimum is going to be met. So I know they're thinking about it, the infiltration's good. And then I see this, which is thermoplastic liner on the bottom. So what they're proposing to do is actually a detention basin, because the thermoplastic liner is impermeable. So this design should not have the impermeable liner at the bottom. So they're saying it's going to be infiltration, but then in their detail, something that many people would probably miss on this if they're not checking the details. Like, okay, we're doing infiltration, this is the size of it, here's the sizing worksheets, but if you don't check the detail and you see thermoplastic liner, the contractor is going to see that and put a liner in. So now your infiltration system is no longer infiltrating. You're not meeting your post-construction requirements, and in order to fix it, it could be extremely expensive. Additionally, with the design here, they don't have any under drains. They don't have any other way of draining it, so they put in a detention system. All the water is going to drain in there and just sit. It can't be released. So then you're not meeting even your post-construction grading requirements for pre versus post. So just a simple little addition to the design here. What I'm guessing occurred here was the engineer did a great job structuring the site, how everything's going to drain, put this in there because they probably checked a standard detail on the vendor's list, and the vendors purposely make these systems to be used for infiltration or detention to expand their markets. So they obviously looked at the wrong detail and put it in here. Simple mistake, but that's also one reason why this afternoon at start of session 4 we do have a couple vendors that are going to come and describe some of their war stories and how to design and implement, because it is very important if you're doing proprietary devices to discuss with the actual vendors. They'll do reviews for you, they'll help you with that, and they'll catch things like this that could be a major cost repercussion later. So I want to shift over to a question I get a lot and never have a good answer for. The 2000, I'm not an arborist, but I but get questions on plant lists all the time, and the county has a plant approved list, but it dates back to like '89. There's really some drought tolerant stuff in there, but that's really the way everyone's going. This was from the original 2000 MS4 permit that was adopted as part of the 2002 Technical Guidance Manual. So it's very limited, lists a couple of species types and a small map that shows what climate zone you're in to pair the plants to. So that could be used for your vegetation, for your vegetated swales, bioretention, but it doesn't list a lot of stuff like, well, how well does it do if it's inundated for 48 hours when you're drawing down a detention or a bioretention area? How much water does it need if you're trying to go sustainable? It doesn't have that information on here. So one thing that's provided by the City of Camarillo, they've adopted this. So this is a 26-page document, and I really like this list. It's got a lot of stuff in here. It identifies different aspects of what I was just talking about, saying, okay, on the far right, identifies, well, in the middle, sorry, it identifies what region, if it's coastal, if you're inland, which kind of plants would be the most appropriate. And then on the far right, it identifies things like water use, as well as if it's in bioretention specifically, this would be good. This one would be good for green roofs. So it's a 26-page document with a bunch of different plant species out there. And it all comes from the Low Impact Development Manual for Southern California. Is developed, I think this was back in like 2009, I want to say. But there's plenty of different plant lists out there that you can utilize. I know Ventura County, I don't know if the City of Thousand Oaks or anyone else has their own, but generally I refer to this when I can now, since it was pointed out to me that that one exists. This is another one that I found from the Central California coast. This is a 4-page how to do bioretention fact sheet. It's a great resource, and on this one, the same thing. They identify what kind of plants they recommend for bioretention specifically. They can handle being inundated. If you go further on, they even talk about ones if you're, like, say, near the harbor, near the ocean, if you're doing bioretention, and salts might be an issue, even airborne or in the soils already, which ones would be best for those. So this is a great resource for bioretention. And then plant establishment. As part of our construction projects, generally in the specs, and I'm writing those, we put a plant establishment period, usually 3-6 months, something like that, but contractors hate it. We don't like monitoring it, but with drought-tolerant vegetation, it's even that much more important. So this is at the Government Center. There's a patch of turf grass that we removed in 2014 as part of a ocean-friendly garden that was done. We held workshops with the community so that they can come out and learn, okay, how do we do sheet mulching to kill the grass so it doesn't grow back up if I'm doing mulch and all this. And then we show them how to plant it, how to use certain techniques to make these more appropriate, and plant selection. So right after construction, here's the mulch, here's the plants that were planted. So that was in 2015. In 2016, it's blossoming a little more, still a lot of bare ground. 2017's gotten a little better, a little more vegetation. And then this was last week I took it, so it's pretty much filled out. So this timeline basically shows you really have about a 3-year period for your plants to reach full establishment to the point you would want them in bioretention or in like vegetated swales if you're not doing turf grasses or things like that. So this is that Happy Valley bioswale. This is the one up in Miners Oaks, the project I talked about earlier, where we were planning to do infiltration. Infiltration came back horrible, so we went to a large bioswale. So this is constructed at the start of 2016. On the far left, we have pictures about a month and a half after we hydroseeded. And you can still see the jute netting on the sides for the erosion control. And then in the middle, this is the next year. So it's a little more spread, and it's the same, try to get the same picture each year from each angle. So the top 3 are at the same location, the bottom 3 at the same location, a year apart. And then in 2018 there, you see it's even filled in more, but we still have patches. And when I was doing the site walk for that, I estimate about 80%, maybe 75-80% of it is vegetated. So we still have a lot of patches where something didn't catch or didn't grow. So we are doing additional plantings this winter prior to the rainy season, so we can help with establishment. But this is 2 years and we're almost there. But we do want that 3rd year and additional plantings to get there. So 3 years is really the plant establishment time frame I would give most people in regards to what to expect. It's important also for public outreach. We ran into a lot of this as well on a few of our projects where residents aren't keen on the idea of drought-tolerant vegetation. They don't think it looks nice. Try to implement the benefits of it for sustainability, less watering. It actually has less maintenance to it. But overall, it's tough to push that in some areas just because it does have a 3-year period before they're actually going to see it the way they want it. So it's just something to keep in mind. Yes?
Did you do a comparison between plant choice in Happy Valley with normal turf for water consumption? And
I haven't. I know Dave is part of Dave was running the watershed friendly garden projects, and I know that the landscape architect was talking about the difference between water use, and I can't remember what the metric was, but he said like water every year uses something like 3 feet of water, if you think of it, and drought tolerant. I don't remember what it is, but we can try to find out for you.
It was like a 80 to 90% reduction from the amount of water needed for the turf compared to drought tolerant vegetation.
Yeah. So it was significant, but we can get those numbers for you if you'd.
this can be used in swales that are prescribed in the TGM, so
They can.
it's just an easy replacement for turf grasses. If we can't put in turf into a swale, you can put in drought-tolerant natives that have similar pollutant uptake.
Correct. Fescue grass. There's also other grasses you can use. Again, I don't know all the common names in that. I'd like to become an arborist at some point, but I'm definitely not there. But there's fescue grasses, other types of bunch grasses you can use. Generally, those are good to space out, maybe 2 feet on center, staggered, so that when those other larger plants and bushes are taking 3 years to develop, the bunch grasses are still impeding the water, slowing it down, kind of acting like as a dissipation device. So that is what I have for section 2. Do we have some more questions? Yes.
I have 4 unrelated questions.
Okay.
So if you're doing ponding for infiltration ponding or bioponding in a, let's say, a park setting, and you have plenty of grass and you have a nice place to do it, or say it's a rain garden sort of situation, maybe in a public used area, is there a maximum depth of ponding to stay below for in terms of safety? Does it cross over to any building code limitations? We've always used kind of like an 18 inches as a maximum so you don't create hazards. But I wonder if anybody has had experience in that.
That's actually a great question. I don't know the answer to that. That is one thing I should look into, though. Because, yeah, you bring up a good point. If you've got excellent infiltration rates, you might have a huge ponding depth. So you might have to put a fence around it or something like that if it's in a, but I'm not sure what that is, so I don't want to. Do you happen to know?
I think that's also covered in table 6-6, maximum ponding depth of 18 inches.
Oh, it is 18 inches? Okay, perfect. There you go.
Thank you, Troy. My second question is sometimes, say in a industrial or commercial setting, you have a parking lot and using storm chambers is the best way to deal with your retention issues for your stormwater quality. But you also have stormwater quantity issues to take care of because of your pre-developed versus post-development retention issues. Are there any issues with putting it all in the same system? Because you're putting an awful lot more water into, sometimes depending on your numbers, but a 3/4 inch detention or retention situation may be a 2.5 inch retention situation for flood control reasons. So you're diluting it, you're flushing it, you're putting a lot more through your pretreatment. What are some of the issues with that?
You, as a designer, you can do really whatever you need to. It is a good idea, though. Generally, I like to do stuff offline for treatment. So if you, for instance, if you take the one example I did where they have the subsurface treatment one below or both below the drive aisles in that one example, they have two different devices. You might want to put like a flow splitter in there with a low flow diversion if you're going to put everything in there to meet both requirements, both your water quality and your water quantity. So you could do a flow splitter so that all the low flows go to one and then your other one acts as a detention system or something. So the main reason is because if you're sending all the heavier flows there, you're going to have a lot more sediment in your and it's going to be, it could be a potential O&M nightmare. So that's really why I like to do stuff in an offline configuration, and I will touch on that more in the afternoon session as well. But there's nothing that precludes you from doing that. You could do, even if you have like an overflow device, like an orifice. There was one project I remember looking at a couple years ago where they were basically building the whole parcel, lot line to lot line, and then everything was draining to one subsurface location, and they had an overflow orifice to release the quantity at a lower rate, but that was set at an elevation where they could show me their infiltration of that 0.75 inches was below that elevation. So there's ways you can do it, but my general recommendation is not to, just because of the O&M aspect.
My third question, when you're determining, in the very beginning, you're determining your project area, two examples. One would be if you had a large parking lot, say a shopping center, but you were only doing the corner of it, and you're building a new store and just doing some parking around there. I can't remember what the definition of the project area is in the TGM, but if you take the entire project area as the property boundaries, you get a pretty large area when you're really just dealing with an actual construction area that's kind of small, but it gives you a bigger 5% allowable infiltration area.
Correct.
So, is that appropriate to take the entire property? Is it property line, or is it project area in terms of where you're working?
It's another gray area in the TGM. The one example I showed you of the EIA calculation had 2 acres of landscaping that wasn't going to be touched, but it was included in the total acreage of the parcel. So the way that is set up in the TGM, it does allude to the fact that it is the parcel boundary. But if your project goes over numerous parcels, then it kind of gets further muddied. So it's a way to hopefully define that within the drainage report of what that total area is. Because I did actually run into one person that came and said, yeah, is out in, I don't even remember what area in unincorporated county, but they had a 26-acre parcel, undeveloped. It was basically just farmland, and they're going to develop a brand new house on one section. And yeah, their design engineer did exactly what you said. They said, here's my project area, which is the parcel, 26 acres. My effective impervious area is 5% of that, which was more than the area they were disturbing. So they said, I don't have to do retention, I'm just going straight to swale. So there's nothing, there's nothing in the TGM that says you can't do that, but I think that's a discretionary standpoint. From a common sense standpoint, that doesn't make a lot of sense to me to be able to allow that type of getting around the regulation.
Because sometimes when you're in the unincorporated area, you might have a large part of your site that's undevelopable because it's steep hillside, but yet it's still within the property boundary, so it kind of bulks your project area that may or may not be fair to the process.
And one way I've seen that addressed is it may be more appropriate to just base it on the sub-drainage area that your project affects. So if you have a 26-acre parcel, but there's a high point in the middle, half it drains this way, half it drains this way, the area that's draining to where your project basically is, that might be more applicable to utilize, especially if you have several different drainage patterns on that parcel. You may be able to come up with a realistic, say, 5-acre area when you're only disturbing like 3/4 of an acre, which would be more reasonable and would require some retention because you're outside of that 5% EIA. Yes?
So it sounds like it's kind of an issue to review these submittals depending on the consultant or whatever the engineer that submits them. But you're following kind of a standardized procedure that appears to be outlined in the TGM. So isn't one approach just to say, hey, follow TGM's standard design procedure and submit it, all these tables and so on that you've got here?
It is. That's generally the way you go about it. From my standpoint, there's some discretion involved in that, but my goal is to have them meet the goals without causing undue burden towards the applicant. So if they're, most of the time I run into it, it's because the applicant or the engineer doesn't know, they've never worked in Ventura County before, they're just doing like this single project, or they're just not familiar with the concepts. So my first design review is generally fairly detailed, identifying, no, you didn't do this, update your hydrology report, I need this. So it's not like we're getting them off the hook. We're saying you still need to meet these requirements, but we may not go through every single step of that TGM because because we don't have a template to go by, every single submittal is different and people organize it differently within their drainage report. And that's really what my goal is moving forward. Is be great to have a template so everything looks the same going to the city of Oxnard as it does to the county of Ventura. And it provides references so someone says, well, how do I do this? Refer to this template. It tells you what section you need to look at, what table you need to include, or we even include them in there so they can't even delete them. So yeah, it's a difficult process, but I think every city, every county kind of does the same thing at this point. Is we don't want to cause undue burden on the applicant. We want to be as reasonable as we can while still making sure they're meeting our requirements.
Because it sounds like the manual really has all these tables, but you're saying it's really too burdensome to make them go through all of it. There's too much there.
Especially for some small projects, like single-family dwellings, they might be doing like a 1 acre, like a half-acre development, or a 1 acre development that triggers the requirements, and then that person, sometimes it's even an architect that does this stuff, and they'll be, I've never seen this stuff before, I have no idea what I'm doing. So I really appreciate it when applicants do come up and like call me and say, okay, what is this project going to need? I know Jane's done that a few times with me. She'll come and, okay, what's this project going to need? So she knows up front, so she can appropriately also bill her clients, because we don't want to see, okay, well, they said we got to do this, I didn't know about it, and all of a sudden the client gets raked over the coals for something. So we try to be as reasonable as we can.
I know we've called you, we appreciate your help in a small city.
Mm-hmm.
And we only see these sporadically, these projects that even hit these triggers. And it's the same thing, you got consultants that have not dealt with them, or they seem to be immediately going to the technical feasibility. It's hard for us to figure out too.
Yeah.
With sporadic reviews and understanding it. So, I mean, the template would be ideal. Do you see it kind of going that way, or is it something we have to kind of develop for our own permit, or is it something possibly they would require the water board?
With the new permit, we may have to, depending on how extensive it is, we may have to do a new TGM. Our hope is that everything kind of stays the same, and then as part of that, I'd like to see an actual template be made as part of that major errata with the new permit that comes through. But we don't know what that's going to look like at this point. That would be my goal, and I hope to be heavily involved with reviews and coordination with the new permit, so hopefully I have some say in what goes through.
Back to the feasibility, you're saying it's in a liquefaction zone? Is that an automatic disqualifier for infiltration?
It's not, but that's also why we require technical infeasibility within the TGM must be signed or stamped by a professional engineer or geotechnical engineer, so that even if they show good infiltration rates, the geotechnical engineer in that report may still say this is not appropriate for infiltration.
Okay.
So that should all be within the geotech report. It's not really your call or my call as a regulator. We just want to say, no, it's up to you guys. You're the professional. You tell me what you want to do.
So like if they say it's okay, then.
Yeah. Yeah.
One last question too. Kind of might relate to the previous question about the area. And it wasn't on the slide. We have got the sizing methodology. Depending on area, there's 5 acres. For example, I was wondering, say you have like a 6-acre site, and there was 2 paths, each were 3 acres, and they were getting ready 2 BMPs. Would your sizing be based on the tributary area?
It is on the tributary area of the BMP itself.
So I had 2 3s, I could use the 3/4 inch rather than 6 total.
Correct. So even in the example I provided as a 12.2 acre site, but I had 6 different sub-drainage areas, so then the 0.75 is acceptable for those smaller drainage areas.
Okay, but if you had one big area, that's what
Yeah. And that just allows them to fluctuate more for larger rain events throughout the years and stuff, doing the other types of modeling in those 3 methods that they propose.
If it takes 3 years for the plant establishment in the case of a bioswale, is it a valuable BMP that could be tied with a development project? Ideally, you wanted something that is functioning when the permit is closed for that, but if it's going to take 3 years, you can't.
And that's a good point. Yeah, with the establishment period potentially being so long, again, there may be other species in that grow quicker that we haven't planted, but that's generally what I've been using as a rule of thumb is 3 years. That's also one reason why you want pre-treatment on everything where possible, because you are at least getting some treatment, especially for sediment. You're removing the sediment so you don't have the turbid water. A lot of the pesticides, other things that might be tacked onto the sediment, you've already removed, so your effluent already is better. So until that BMP meets full needs, we've run into the same thing with our grant projects that we've done, is that bioswale, for instance, that I showed the planting. Part of the grant application has like a set timeline for when you do your water quality testing. So as soon as it's done, we had to do water quality testing, and it looked horrendous. So we're implementing, okay, well now 3 years later, like next year, once we get everything established, we're going to redo it to show these actually work, because when there's sediment available to be washed down, you get high sediment loading in your effluent too. So you got to make sure you have good ground coverage to even start doing your water quality sampling from grant projects as well. Anything else? All right, that actually worked out pretty well with timing. So we'll break for lunch, and please be back. We'll start right at 1 o'clock.